So this is an important idea in stats, something called the law of large numbers. Anytime in math that they call something a law, you know it's probably pretty important. The law of large numbers basically says this. It says the more times you repeat an experiment, the closer that you're going to get to what you would expect the probability to be. Okay, so what is this graph showing right here, the number of tosses? So let me give you an example of this. Basically, suppose I toss a coin 10 times. It's possible, it's very unlikely, but it's possible that you could get 10 heads, right? That could happen. Or not 10 heads, you might get 9 or 8 or something, but it's not necessarily going to be the case that you'd get what you would expect. The theoretical, or what we call the classical probability, classical is another name for the theoretical. If I asked you what would you expect to get based on the 50-50 chance of getting heads if you tossed it 10 times, you'd probably tell me I expect to get 5. Expect to get 5 heads, but that might not happen if you only toss it 10 times. On the other hand, if you toss it 1,000,000 times, it is almost impossible that you're going to get 1,000,000 heads or 900,000 heads. It's almost sure that you're going to get somewhere very, very close to 500,000, very close to half. That's what the law of large numbers says. It says even though you could get these strange events happening for small numbers of tosses, for really big numbers of tosses, you're going to get about 50-50. You'll get exactly what you would expect. Okay, so there is a little website here. It's called Virtual Coin Toss, and I'll show you what it looks like. All right, so here's the site, and you can see I've already flipped once, but looks like I just got a tails, and then I got a heads, and so on. You can see down here, it looks like there's been, trying to see what that number is, it looks like 38 million people have flipped things. And if you look at the numbers, it's about half and half, right? Even though tails looks like tails has about 13,000 more. 13,000 is almost nothing compared to 38 million. If you were to put this number right here over 38 million, whatever that is, it's going to be just about 50%. Okay, and you can see when I'm doing it, let me just flip a whole bunch more times. I flipped 10 times, or it looks like 15 times. I'm getting a lot more heads. But if I were to keep going 15 million times, I'm going to get about half heads. That's the point of the law of large numbers. All right, so we just talked about theoretical probability. Another name for that is classical. Classical is what we would expect to happen. So heads, we would expect for 10 heads, we're going to get, or 10 coin tosses, I'm sorry. If we flip 10 coins, classical probability tells us we're going to get 5 heads. Empirical probability, that's another thing we talked about. Empirical means you actually run the experiment and you see what happens. So maybe I toss 10 coins and maybe I get 7 heads. That's what actually happened. Okay. The third and final type of probability is this right here, subjective. If somebody asks you to give your subjective opinion, means what do you think is going to happen? So you can see there, it means basically estimating probability by making an educated guess. So a good example of this, if you go to the doctor and you have a disease, the doctor says, I feel you have about a 90% chance of getting better. That's an example of what's called subjective probability. All right, business analysts could do the same thing. Maybe there's a 25% chance people go on strike. They're not actually doing it like we are here. They're not calculating anything. They're just making an educated guess. So let's try to distinguish those three with an example. We want to tell, is it classical, is it empirical, is it subjective, and why. This is important to explain our reasoning. Probability that we'll get an A on our next test is 0.9. Well, that's not like a coin toss, right? There's no coin toss like reason why I should get why there's a 90% chance I get an A. So it's not classical. Empirical, it can't be empirical before I've actually done it. Okay, so if you actually get a 90, then you can say that it would be empirical. But really here I'm just making an educated guess. I've done pretty well in the class. I have about a 90% chance of getting an A. So that's subjective. Number 2, the probability that a voter chosen at random will be younger than 35 years old is 0.3. So we have to assume that we have a survey of voters. Let's say I've polled all the voters and I have their ages. We have to assume that we've actually run this experiment and we have their ages. And that way I can just look at the ages and see. So if I've run the experiment already, that means I'm dealing with empirical probability. I'm looking at some results that I've gathered, and that's how I'm getting the probability. Number 3, the probability of running a 1,000-ticket raffle with 1 ticket is 1 in 1,000. So the question to ask yourself is, do you have to run the experiment right there? Is it necessary to actually run the experiment to tell? And the answer is no. If there's 1,000 tickets and you buy 1 ticket, Well, what would your chances be? 1 in 1,000. Do you actually have to hold the raffle to tell? And the answer is no. It's just like tossing a coin. I don't need to toss a coin to know that I have a 50-50 chance, because that's in theory. If I actually were to run the raffle and find out that I came up with a different result, that would be a different story. But that's a good example showing the distinction between those three types of probabilities. Classical is what you would expect. Empirical is what actually happens when you do the experiment. Subjective is just making an educated guess.